The Skymaster is the odd twin that behaves like it didn't get the memo about asymmetric thrust. If you lose one engine on this plane, it flies straight like a single as if nothing happened. It was so good that at some point, pilots couldn't tell when the rear engine failed. Most people either absolutely love the Skymaster or they can't stand the sight of it. I personally think it is one of the greatest planes ever made. I wish someone tried a modern, certified, sleek composite push-pull twin. I wonder how that will stack up to the Diamonds, who basically outsell everyone else put together. So basically, back in 1959, the Cessna 310 has been on the market for about 4 years, but at a $60,000 base price, a lot of pilots who wanted multi-engine just couldn't touch it. So Cessna, being Cessna, basically said, "Fine, we'll build something for those pilots." And they told the design team to come up with a light twin that could work off small or rough fields and still cruise around 180 miles per hour. The problem was that you couldn't really cheapen a 310 into that airplane, so the designers had to start clean. They sketched everything: high wing, low wing, pushers, tandems, conventional twins, the whole menu. Then in late January 1960, they got the green light for the high wing tandem twin idea. So that idea became the Skymaster concept, and it got the model number 336. Cessna's plan was basically build a Cessna high-wing single but twin, except with engines front and back, one pulling and one pushing. The fuselage sat between two booms running aft off the wing, and the tail was twin fins with one horizontal stabilizer tying them together. Even though most twins of the era were retracts, Cessna kept it fixed gear once they figured they could still hit the target speed with fixed gear setup. This kept costs down and made it attractive to lower-time step-up buyers. Power came from two 195 horsepower Continental IO360s, and on paper it looked brilliant. Despite that, pushing is a bit more efficient than pulling. Rear engines have cooling issues as a result of messy airflow. Cessna tried to fix this by grabbing air through forward-facing scoops near the trailing edge of the inboard wing and dumped it out aft through a complicated augmenter tube setup. Flight tests basically said, you just need a big opening at the back of the cowl. But that made the cabin loud, so they added a movable scoop on top of the cowl and a fan in the rear opening to help. Designing the control runs was a bit more complicated than a conventional tail, where everything just runs straight back. They routed the empennage cables through the wing struts, which created this awkward winding path with a bunch of pulleys sitting at odd angles. Once flight testing started, it was basically high-friction city. They pulled out 7 pulleys, and that finally cleaned it up. On the system side, they put the auxiliary fuel pumps in the wing leading edges and tucked 3-quart sump tanks into the tail boom area under the wing. The flaps were big Fowler flaps outboard of the booms, 30% cord and 8 feet long, and the ailerons were 5 feet long at 29%. Looks-wise, the Skymaster was striking until they slapped on the fixed gear with wheel pants. Somebody said it was like seeing Miss America in a swimsuit wearing GI boots, which is brutal but fair. During the test flight in 1961, test pilots stated that takeoff and climb performance and the creature comforts were great, but the longitudinal stability and the lack of elevator power weren't particularly the best, partly because those controls were still high friction. Cessna worked on the controls, and a second prototype flew in March 1962, and a little over a year later, the first Skymaster got delivered. From a safety angle, the industry saw the 336 as a landmark. Lose an engine, and it was barely noticeable, especially if it was the rear one. Torque and P-effect were canceled because the props turned opposite directions, and power off, flaps down stall speed was 52 knots, 60 miles per hour. But here's the thing. When the Skymaster finally hit the market, the press loved it, but the flying public basically shrugged. Cessna sold only 102 in the first year, which is a lot today, but not by 1960 standards. A lot of pilots mocked the safety features, saying they could handle engine outs the normal way. And the safety record wasn't kind to it either, because since the Skymaster attracted lower-time step-up pilots, the incident and accident stats got skewed, and the biggest practical complaint was identifying a dead rear engine. The controls weren't foolproof. The POH basically told you to check the gauges, then bring in the rear throttle, and listen for the sound change. The looks didn't help either. It wasn't as sleek as a 310, and it wasn't even as fast as a 210, but it still had a chance. And the funny part is, by the time the 336 hit the sales floor, Cessna had already decided they were going to take the GI boots off Miss America. So this is where Cessna basically admitted that they misjudged the market. They honestly thought a loyal crowd would line up for an inexpensive, safe, but kind of goofy-looking fixed-gear twin that only cruised around 173 miles per hour. But the market, bluntly, seemed to care about two words: inexpensive and twin. So Cessna decided they had to go retractable. And turning that fixed gear into retract gear meant compromises. Lots of them. Cessna thought they'd already learned that lesson back in the 1950s when they turned the 180 into the 210, but the Skymaster made it even messier. Because tucking all that gear into the fuselage on this airframe took some serious origami, and the lame duck look when the gear was halfway up or down became legendary. The gear they ended up with also put the airplane 4 inches closer to the ground. Once you remove that gear drag, the aerodynamics change a lot. The wing incidence changed 2.5 degrees, and the cowl ended up sloping more downward. They also reworked the rear engine cooling setup, replaced the rear engine air scoop, and ditched the fan. The elevator got a 4-inch chord increase, and the ventral fins were shortened by 6 inches. They tried adding wing flaps inboard of the tail boom attach point 2, but testing showed they had to limit those inboard flaps to 25 degrees when the outboard flaps went to 40 degrees. Then came the weight creep. Gross weight went up by 300 pounds, and with the expectation of better performance, customers started pushing for 5 or 6 seats. So engineers came up with the exterior belly-mounted cargo pod. They also tried to make the dead rear engine identification problem less nasty. They raised the rear engine idle speed by 50 RPM so it sounded different from the front engine, and the handbook suggested leading with the rear throttle during taxi and takeoff. Put all that together with the retractable gear and a few smaller tweaks, and the ugly duckling turned into a sleek 200 miles per hour airplane. The Super Skymaster first flew on March 30th, 1964, and 1966 model deliveries started in fall 1965. Then in 1967, they integrated the turbo system into the 337, and cruise speed jumped to 225 miles per hour with a service ceiling over 30,000 feet. After that, the pressurized Skymaster debuted with a 235 miles per hour cruise speed. Price-wise, it was $76,500 base in 1973. About $98,000 average equipped, and by 1980 it had climbed by nearly $100,000, picking up nicknames like Mixmaster, Push-Pull, and Push-Me-Pull-Me, but officially Super Skymaster was used for all 337 models from 1965 to 1971. From 1971 until production ended around 1982, it was just called the Skymaster. So not long after the Super Skymaster showed up, the designers went, what if we do a lower-powered version of this thing? And that's where the 327 comes in. It was basically the same shape as the bigger 337, but it was a 4-place cabin, it used a cantilever laminar flow wing adapted from the 210, and it ran 160 horsepower Lycoming 0320s. On paper, the projection was about 190 miles per hour top speed, and they were expecting the construction and structures to be simpler too, but in reality, the performance just didn't hit the targets. They put 39 hours on the prototype. Then in May 1968, they swapped in two 180 horsepower IO 360s. That pushed it to 198 miles per hour at 3,500 pounds, but even then, it still wasn't enough to compete with the Piper twin Comanche. After another 44 hours of flight testing, they pulled the plug and canceled the program in August 1968. It's hard to judge how Skymasters stack up out in the real world because it lived in this weird overlap. People weren't cross-shopping it against just one category. They were bouncing between light twins on one side and big high-performance singles on the other, depending on what they actually wanted. If you were in the efficient 4-seat light twin mindset, you basically ended up staring at the Piper twin Comanche, the PA 3039. But if you slid from efficiency into prestige and business travel, now you're in Beach Baron 55 territory. Push the same money toward a fast traditional Cessna traveling twin, and the pull is the Cessna 310. Flip the mission from chasing speed to just lifting people and bags, And that's where the Piper Aztec, the PA-23, shows up as the proper load hauler. And if you keep coming back to the question, why do I even need 2 engines for this trip? The obvious alternative is the Cessna 210. Same basic travel profile, just way simpler ownership. When you look at the competitor numbers, take the twin Comanche. You get about 853 pounds of full fuel payload, and it'll cruise 168 knots on about 17 gallons per hour at 75%. So you're carrying roughly the same kind of real trip load, but the efficiency story is cleaner, and that's why it outranks the 337 on economy per knot. Now step up to a Baron D55, as tested, and the whole picture shifts. Payload with full fuel is about 1,100 pounds, and it'll do about 200 knots at 75%. That's closer to 5 people with bags, and you're doing it faster in an airplane people see as premium, so it beats the Skymaster on speed and presence. Then you've got the late model Cessna 310. Using max useful load as the basis, with 102 gallons on board, you've got huge payload potential, and the speed is part of the whole pitch. About 183 knots on 25 gallons per hour for the 240 horse versions, and roughly 190 knots on 29 gallons per hour for the 285 horse versions. So anyone shopping fast-traveling twin would naturally slide towards the 310. And the Piper Aztec is basically built for the thing most 6-seat pistons only talk about. With a useful load of about 2,200 pounds and 144 gallons of fuel, it's described as the one where you can fill the seats, fill the bags, fill the tanks, and still be within limits. It just wins the real hauling argument. Then there's the Cessna 210, which is the closer you have to respect. It cruises 165 knots and can carry more than 1,000 pounds with full fuel. Exactly why it steals the buyers who want the family travel mission to work, but don't want twin costs, twin maintenance, or twin insurance. So once you line the market up like this, the Skymaster's issue is pretty simple. It doesn't fall apart, it just doesn't dominate any one column. The second a buyer decides what matters most, there's usually another airplane that beats it clearly on that one thing. When you look at real-world range, most headline range figures are really just slow down and lean hard numbers, not loaded up and go travel numbers. With the Skymaster, the long-range tank setup can play the endurance headline, but look at the trade. The example is basically 150 knots for 7+ hours while carrying only about 650 pounds of payload. That's not 6 people traveling. That's endurance mode with a light cabin. A lot of the 337's real downfall came from how it was positioned. Cessna sold it as the safer, simpler step-up twin, but the people who actually bought twins wanted speed, status, or capability, not theory. So the Skymaster kept getting treated like the clever alternative instead of the obvious choice. And because its 6-seat claim didn't hold up in real loading, it never owned a clean mission the way its competitors did. The human factors issue didn't help either. Centerline thrust removes the big yaw cue that normally tells you instantly which engine quit, and that weaker seat-of-the-pants feedback meant wrong engine shutdowns showed up more than anyone liked. Once that reputation took hold, insurers tightened up and the easy step-up buyer vanished. When the early 80s downturn hit, the writing was on the wall. Low-volume models that needed extra explanation were the first to get cut, and U.S. production of the 337 effectively ended around 1980, with only small-scale Rhymes builds carrying on briefly after. Truth is, one lever could have changed a lot. Cessna needed to lock the mission early and stick to it. Sell it for what it really was, with honest payload and range numbers, and back it with a proper transition program so the wrong engine stories never became folklore. Without that drift, the Skymaster might have held its niche instead of getting squeezed from every side. So that's it for today's video. Don't forget to like, subscribe, and ring that notification bell. It goes a long way for us.